All right, good morning. I apologize for doing this to you 2 days in a row. I actually am in the building today, but I have some other things that I have to take care of today. So please do be on your best behavior. Um, Here's what we're going to do today. So today I'm treating as the review day for this unit. We're going to do some practice problems, and then I'm going to give you some time to work on the final exam review guide. Um, Homework, which you should know about by now, is you should be working on the review guide. That needs to be done on the day that you take the final. So seniors, that's a day earlier for some of you than everybody else. But make sure you don't forget to work on your final exam review packet. Please make sure that you remember that we have an equivalent resistance quiz on Friday. And if you have that bonus problem and you want to do that, that needs to be finished by Friday. So I wanted to show you real quickly what we've got coming up. So today, like I said, we're going to do some review. Next time I see you, we've got a lab. And then on Friday, we're going to take that quiz. And we will have a little bit of work time on your review after that quiz. But I want to show you how quickly the final exam is coming, because next week, we aren't in school on Monday. Tuesday, I've got a review game kind of like we did last semester that we're going to do. And your final exam is going to be either Wednesday or Thursday of that week. So you should be pretty well started on your final exam review packet now. After today, the only time that you've got in class to work on that is Friday. So make sure that that doesn't sneak up on you. One other thing that I just want to make sure to say about that is, you're allowed to skip a certain number of problems, but every year I have some people who end up, for the problems they didn't skip, the problems, the free response problems, they don't write any work for them, right? If you don't write any work, I'm counting that as one of your skipped problems, right? And if you don't have any work for any problems, the best you can do on your final exam review packet is a 5 out of 10. Please don't do that, right? You can get there's no reason you shouldn't get a full 10 out of 10 on the review packet, plus the bonus that you do on top of that. But please don't just copy down answers. Obviously, a lot of it is multiple choice. There aren't very many that I ask you to show work on, and I let you skip a few of them. So on the ones you don't skip, I expect to see some work. All right. Okay, so today, like I said, I want to work on electricity number 4, and I'd like you to start. I'm going to have the sub pause the video for a few minutes here, and I want you to write down as many things as you know about series and parallel circuits. Okay, so hopefully you've had some time to write now. So there's a couple things that I just want to make sure that you're good with if we do series and parallel. Right? Let me see here. So a series circuit, remember, has only one path for electricity. And a parallel circuit has multiple paths. All right. But you also know what is the same everywhere in a series circuit. A series circuit has the same current everywhere. Remember, that makes sense, because if you only have one path for electricity, you've only got one way. I mean, everything has to have the same current, right? If I draw a simple, if I draw a simple series circuit, right, and you imagine the electricity flowing around here, whatever speed it's going here, it has to be the same speed as it's going there, because it never has any time to branch off, right? Okay. The other thing that you should know about a series circuit, and this is, and I've said this a few times, but this is going to be a question on your quiz on Friday. In a series circuit, when you add more resistors, the equivalent resistance goes up, I also want you to tell me why, right? Remember that this makes sense because all electricity has to flow through every resistor. And since it has to flow through every resistor, it's going to slow it down. All right, so let's talk about parallel circuit. So parallel circuit has multiple paths. I'm going to draw a basic parallel circuit here. So here's two resistors in parallel. So again, what's the same everywhere in the parallel circuit? What has to be the voltage that's the same everywhere in the parallel circuit, because every resistor is hooked directly to both sides of the battery. It does not have the same current everywhere, but it does have the same voltage everywhere because every part is connected to the same battery. And in a parallel circuit, when you add more resistors, the equivalent resistance goes down. Again, why does it go down? Because the electricity has multiple paths. So it can get through the circuit more quickly. So guaranteed question on Friday's quiz. What happens when you add resistors in series? What happens when you add resistors in parallel, and why? Okay, I'm going to give you a minute. I'm going to have this pause this again, and I'd like you to take a minute to try answering question number 2. All right, so hopefully you've had some time to try it. So if I'm doing this, first thing I gotta do is calculate equivalent resistance. So I'm gonna look for my series circuits first. I see 2 series circuits here. And the equivalent resistance I just add, 1 plus 2 plus 3, which is 6. And 5 plus 3, which is 8 ohms. When I redraw my circuit, I got a 4.5 volt battery, but now I've still got this 4 ohm resistor. But instead of those combination of resistors, I've replaced this one with 6 ohms, right? And I've replaced this one with 8 ohms. So now this is a simple parallel circuit, and I can do the equivalent resistance like this: 1 over 8 plus 1 over 4 plus 1 over 6. I believe that the common denominator is 24. This is 3 24ths plus 6 24ths plus 4 24ths. So that comes out to be 13 24ths. 1 over REQ is. So REQ is going to be the opposite of that. So it's going to be 24 over 13, which I'm getting to be 1.85 ohms. There's part A. I'm going to actually have to switch videos here just a second.